Hi everybody and welcome to level 4 of transformations. Right now we're going to do some transformations that involve dilations, reflections, rotations, and translations all in one problem. So pay close attention and remember to rewind if anything gets a little too fast or confusing. So let's look at this problem here. It says dilate at 2 over 1, then translate x minus 5, y minus 4, then reflect in the y-axis, and then rotate 90 degrees. So this is our figure, this is our origin. The first thing we're going to do is dilate it at 2 over 1. So what I can do is figure out what some of the coordinates are and then dilate the coordinates. So this is 1, 2, 3, 4, 0, 4, comma 0. So if we're going to dilate that at 2 over 1, it kind of looks like this. 4 times 2 over 1, comma 0 times 2 over 1. Now the math here is really easy, but it's a good way to remember how to do it. 4 times 2 is 8, 8 over 1 is 8. 0 times 2 is 0, 0 over 1 is 0. So our dilated point will be at 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. So this point will be here. This one here is 5, 0. So we kind of do the same thing. We do 5 times 2 over 1, comma 0 times 2 over 1. 5 times 2 is 10. 10 divided by 1 is 10. So it's going to be 10, comma 0 times 2 is 0. 0 over 1 is 0. So 10, comma 0. Well, if this is 8, 0, it's going to be this point. And clearly, we just double the size of everything. So instead of going across one box like we did in the original, the image we're going to go across two boxes. And our image is going to look like this. So there we go. We're done with our dilation. After the dilation, it says translate x minus 5, y minus 4. So I'm going to choose this point. I just like it. It doesn't really matter which one you choose, but I'll choose this one. Do x minus 5. That means 5 to the left. 1, 2, 3, 4, 5. And then y minus 4, that's 4 down. 1, 2, 3, 4. So this point translates to this point. I can also translate a second point if I want to help me see it. I'll translate this one. 1, 2, 3, 4, 5. 1, 2, 3, 4. So now I've got these 2 points. Clearly it becomes pretty easy to see that this is my translation. Okay. Next it says reflect in the y-axis. Now that means we're going to cross it over the y-axis. So the y-axis is this line that lines up with the origin. So if we're going to reflect it, it means we're going to bounce it to an equal distance on the opposite side. So this is 1, 2, 3. So I'm going to go another 1, 2, 3 to find its corresponding point. This one is 1, 2, 3, 4, 5. So another 5. 1, 2, 3, 4, 5 to find its opposite point. And this will be our reflection. So you can see it's the same exact distance from the y-axis. So it's exactly the opposite, the mirror image of this one here. Last, we have to rotate 90 degrees. So rotations are probably the hardest part. But remember, what we do with rotations is we create vectors. So a vector is a line or segment that extends from a point to the origin. And what we're going to do is we're going to compensate every part of it. So if this one has a y component of 2, then this one's going to have an x component of 2. And if this one has an x component of 1, 2, 3, 4, 5, then this one's going to have a y component of 5. 1, 2, 3, 4, 5, 1, 2. This point becomes this point. This one here, so as you can see, the two vectors make a 90-degree angle. This one here has a y component of 2, so it's also going to be 2. But the x component is 1, 2, 3, 4, 5, 6, 7. So we're going to go up 7. So if this is 5, this one's going to go 2 up, so it's actually going to be slightly off, but that's okay. It's easy to count. Let's move to this one. This one here has got a x value of 3, so that's 1, 2, 3, and a y value of 1, 2, 3, 4. So what we're going to do is an x value of 4 and a y value of 3. So here's 4 and 1, 2, 3. There's that point. I think it's pretty easy to see what the shape of our final rotation is going to look like. It's going to be right there. So we have our original, we have our dilation, we have our translation, we have our reflection, and we have, last of all, our rotation. And that's it for number 1.